And now we're just going to do a little algebra, basically. So let's rearrange it so that it's u dv dx, and then we move over the d dx of u times v. Good. So we just kind of swapped these. And then what happens if we take the integral of both sides? So what's going to happen here? We're going to get the integral of u dv. What happens here? We get u times v, right? And here, we're going to leave that integral of v du. Okay, good? Good morning. I may have seen somebody walk in with a couple Starbucks drinks.
Yep, that would be my sister.
Okay. All right, so what we're going to do here, we're going to make, so we have to kind of take this apart, and we're going to let u equal x, and we're going to let dv equal cosine x dx. On the next page, I'll tell you why we're going to choose these. All right, so we're letting u equal x, and this whole part is going to be our dv. Good? Okay. So, what's du? 1 dx. And working backwards here, dv is equal to cosine x dx. What would happen if we integrate that? We get, yeah, don't worry about the plus c. We'll do the plus c at the very end. Okay, now we're going to use that formula. So the integral here. So it's going to be uv. So u is x, v is sine x. So x times sine of x minus the integral of v du. Sine x, what was du? dx. Okay, now we have one more step. Now we integrate sine of x. So we get x sine x plus cosine x plus c. Because if we look back at the original integrand, there's no way for us to do u substitution. There's no other way for us to integrate this, so we have to take it apart. So that's why we call it integration by parts. Good? Okay, now how did I know to make u equal to x and not u equal to cosine x? Well, one, if I made u equal to cosine x, I'd just get into this loop where I'd never be able to take it apart. But we also have an easy way to remember. Lip it. Every year, yes, you can make up whatever helps you to remember it. I just remember the word, lip it. Sometimes people come up with a morning. So let's talk about what does the L stand for. So we're basically going first choice to last, depending on what's in the actual integrand. So first, if you have a logarithm, we make that equal to u. So that's how we're choosing u. Okay. If there is not a logarithm, then I stands for inverse trig function. If there isn't one of those either, then P is polynomial. And then E is for exponential. And lastly, a trig function. Those are the only ones that we'll have to encounter. Good. So looking back, right, x, that would count as our polynomial. That comes before our trig function, so that's why I chose the x. Good. All right. So lip it. Okay, so x e to the x, what would we choose to make u equal to?
X.
Polynomial and then exponential function. So
X.
the x. So again, yeah.
Can you redefine polynomial for what it means?
Oh, polynomial. Okay, so polynomial.
Isn't it just like a thing with multiple?
It's like basically anything.
It doesn't have to have multiple.
Well, some examples would just, well, it could be x. It could be x squared minus 3x. It could
That's what
be.
I was thinking. So how? Okay. So it can. So like a loner, like a lone. X.
Yeah, it could be 5x cubed.
Okay.
Bless you.
Thank you.
It could be one single term, or it could be multiple terms. Okay. The polynomials that you'll have with these are not super complicated. Okay. They're usually going to be like x squared, x cubed. Like you're not going to have really complex polynomials that we have to work with. That would be kind of a nightmare to have to do. Okay, so first we're going to so again, we want to figure out what u is equal to and what we're going to make dv. So we're going to make u equal to x, and everything that we're left over with. So dv will be our e to the x dx. Good. So we work forward, derivative here, work backward here, antiderivative. Good. So that means du is going to be 1 dx, and what's v equal to? E dx. Good. So uv minus the integral of v du. Right? Look back at the previous page if you forgot. Good. uv minus the integral of v du. So go ahead and rewrite that integrand into those separate parts. Right, that's our formula.
Yeah.
So what do we get? Just
X e to the x minus e to the x plus c.
perfect. All right. Good. Next one. What are we going to make u equal to? X squared. So let's let.
Repeated use.
Yes. So sometimes we have to. What's that?
Is it because it won't be equal to just dx the first time? Like, because it'll be 2x
Yeah.
for du?
Oh, sorry. So sometimes one integration by parts is not enough. Again, when do we use this? This is used when we can't do u substitution, we can't do straight integration. There's no other way to do this other than taking it apart.
I have a question.
Yeah.
Let's just say we like it's two things multiplied by each other, but technically you could do substitution, like we missed it and we did this instead, would it work?
Yeah. Yeah.
Like if u substitution was possible, but like we missed it and we just went straight to this, like it would be okay.
Yeah. It would overcomplicate it, but it would still work. Okay.
I think that's a mistake.
Good. Yes.
For the example 2,
Uh-huh.
I don't. Why is it the integral of x e to the x dx instead of just the integral of x? Because on the other page it's like it's just the formula is the integral of u, but isn't u
Oh, okay. I think what you're mixing up here is we're taking, what we have to do is, this is our taking it apart. We're reestablishing what these two, remember, you technically can't do this because they're different variables.
Right.
So that's why we're using this method of integration by parts to rewrite it,
Oh, because then you plug in the.
because we want to have everything in terms of x here. We shifted everything around, so, right, we can't actually integrate u dv. That doesn't make sense. Okay. So, what do we have so far?
No, not just 2.
This should be just twice. So it's uv, so x squared e to the x, minus the integral of v du. But I have, this is my situation here. Now that 2, I probably would just put in front of the integral. But what would we make? So we'd have to make u now. So our new u would be what? Or if you want to make it 2x, it's fine. You want to just make it 2x and we'll deal with it? That's fine.
Wait, are you not supposed to make it 2x?
I was saying you could put the 2 in front of the integral, it's just a
So
coefficient.
clever. That would have been clever.
Oh.
But it doesn't matter, it doesn't matter. We'll get the same answer.
Oh, okay.
Okay, and then we'll make dv
That's so much
our e to the
smarter.
x dx.
That's so much smarter.
So du would be 2 dx and v is e to the x. Okay. So this first part we're just going to leave, but the second part, now we're going to rewrite that and integrate one more time. Good? So x squared e to the x minus uv plus, right, because it'll be minus negative, right?
2e to the
See how I was saying, like, if you just pull that 2 out in front, then you don't
Yeah.
have to really worry about it. So, but that's fine. If you want e to the x plus 2 e to the x plus c.
It's annoying that something so simple turned to that.
Good? Yeah? All right. Now we want to solve the initial value problem. What are we going to make u equal to this time?
ln of x?
Good. Flip it. So we're going to let u equal natural log of x, and dv will be,
X cubed,
yeah, so just remember taking that original differential equation, moving that dx over, and then ah. All right, so go ahead. What is du and what's v?
du is 1 over x.
Du 1 over x dx and v 3x squared. Or sorry, why did I do that?
X. to
Thank you.
the
I
power
know.
4 over 4.
X to the 4th over 4. Okay, what's that become? So z equals, so uv minus the integral of v du. So v is x to the 4th over 4 times 1 over x dx. So nothing really that we can do. I'm going to just move the x to the 4th in front so we don't accidentally do that. So this is really what, x cubed over 4?
Yeah.
So if it's x cubed over 4, then it will become, right, this whole thing right here.
X to the power of 4 over 16.
Whoops, I didn't mean to write that. I wrote that backwards. We said it was x to the 4th over 16 plus c. Good? Okay,
Wait, don't we?
now we want to solve for c.
Oh, okay.
'Cause- yeah.
Okay.
We're good. So now plug in 5. 5 here. And then plug in 1, so it'll just be 1 natural log of 1, which hopefully we remember.
0.
Oh, so that whole thing just goes away.
Yeah, that whole thing just goes away. And so 5 and 1/16, or 81 over 16.
Good job.
And that's,
Yeah.
now, we don't have to find a common denominator. If you really want to, go for it. Just. All right. One more example, and then we'll pick the next part up.
You said this one was your favorite.
The tabular method. I know, I'm tempted. Maybe we should do it today. The reason I'm gonna save that is because that's the shortcut to this.
Oh.
So
You want us to
remember when you
struggle
do like
tonight
all
on the
those
homework?
limits and then you learn like the power rule? The only problem is this problem cannot be, there's no shortcut for this one. The two previous ones,
Is it
all the previous.
so it's like the U substitution shortcut where it's only in certain
Yeah, it's like
situations.
it only works in certain. It only works if you have usually like a polynomial, and you don't. You have to have like a polynomial and something easy that you can integrate. So
Don't worry about it.
this one's a bit long though. Sorry. Okay. So we want to integrate e to the x cosine x. So what are we going to let u equal to? Lipit. Lipit.
Logarithm.
Logarithm, inverse trig,
Then
polynomial, we don't have.
Exponential and then trig, so.
Exponential,
Exponential,
so u has to be,
I'm sorry, man. You can just skip that a little bit.
I know, I'm working on memorizing.
Okay, sorry, man.
all right, let's see what happens. There is a reason there's only one
Yeah.
example on this page.
Is it just gonna keep? It's just gonna keep looping through and
Okay.
e to the x every time.
Yeah, what happens with, so du we know is e to the x dx, and what will v will be sine x,
Sorry.
right, integrate.
Oh,
Okay, so the integral of e to the x cosine x dx equals uv, so e to the x sine x. This also there's no shortcut for, so we have no choice but to do it like this. Minus v du, so it's going to be sine x e to the x dx. Oops, got my info. Okay, so we're gonna have to do that again, right?
Yeah.
Okay. So now we're gonna let, same thing, right? And we'll make the trig function our dv.
Maybe in this case, in this thing, it says that you can make it an exponential or a trig function for the last one. Like, are they the same? Or does exponential come first? Like, if you chose,
I usually do exponential
like,
first.
if we chose cosine here, would we still have the same problem?
We still have the exact same problem.
Oh, okay. Oh yeah, because
right? Because it'll just keep looping. This will
Okay,
just keep
yeah.
giving us e to the x every
Yeah.
time. And if we integrate, it'll be the same thing.
Yeah, no.
And the trig, same thing. You will get sine, then cosine. So it's like equal amounts of work, if you will. So du is e to the x dx, and v this time will be negative cosine. Okay, so e to the x cosine x dx will be e to the x sine x minus u times v. So that'll be minus and negative, so we can change it to plus. E to the x cosine x.
It's also still plus again.
Well, no,
Isn't it minus the whole?
Yeah.
thing?
Well,
It's order of operations.
here. I'll write it out just so we can see. E to the x,
It is. Am I wrong?
wait,
Okay.
sorry. No, wait, it should be,
Yeah, because so both of them end up being plus.
yeah, they'll both end up being plus. No,
But yeah, there is except for the negative cosine, but that's after you integrate. For both of them. Okay.
right, the integral, so it's minus negative cosine x times e to the x dx. You said the same thing? Okay.
This is gonna end this go forever.
It could go forever,
Now
but,
we have the same integral from the beginning.
so it's gonna be plus e, yes.
Oh, so it will go forever.
But you can plug in what we got for this.
I'm gonna, there we go. Aren't those the same terms?
Yeah.
So if we add this to both sides, I'll end up with 2 integral of e to the x cosine x dx. And then divide both sides by 2.
Oh, wow.
That is pretty cool.
Now you see why we only have, I think, 4 problems for homework.
So for this one, you would wait until you get to the
5.
to
Yeah.
have the same
Yeah,
on both sides.
What's
And
the
then we'll put a
longest- what's
pussy.
The longest that they'll go.
yeah, for something like this, if you have an e to the x and you have a sine or a cosine, you're gonna look for like terms. You're just gonna have to rearrange things. That's basically it, and then you divide by 2. That's all. But don't keep going because you should recognize that these are the same.
Yeah, we only went twice. You don't actually go that much.
It's fine. It still takes how much paper? Were you able to fit it all
Yeah.
on one page? Okay. That's it. So